A short introduction. I've been doing professional software development for over 20 years. I do feel like a dinosaur sometimes. My first lab was software engineering, but over 5 years ago, I joined the dark side of platform engineering. And guess what? I absolutely loved it. For last 10 or 15 years, I've been working on automated tools for detection and refactoring of various software defects, including security vulnerabilities. So basically, security is my daily job. What am I going to talk about today? Just a splash of theory and what's going on? Where does it come from? Okay, it's... And this is their next show. Okay, it's better now. So what am I going to talk about today? Just a splash of theory in the ocean of practice. So the key part of today's talk features 5 demos. However, I'm not sure if we're gonna do all of them because we do have pretty limited time and tight schedule. But at least 3 of them we can do, I think. Fingers crossed. So why should we care at all about security and pod escape? Well, there are real-world risks and real-world examples where pod escapes allowed to gain the ultimate access to entire cluster. So that was the ultimate compromise. Think about all those multi-tenant clusters, think about software as a service, and even in a single tenant environment, you can, with pod escape or some security misconfiguration, you can end up with fully compromised cluster. So there were several famous or infamous vulnerabilities like RunC CVE in Azure, where RunC allowed for container breakout by overwriting the RunC binary on the host. Another problem is usually with exposing some sensitive data like tokens or secrets, anything like that. That was the case of GKE and instance metadata, which were accessible by default. Also, another one is Capital One breach in AWS. It was not per se Kubernetes specific, but the idea behind it is the same. So basically, SSRF, server-side request forgery attack allowed to access EC2 metadata API and leaking IAM tokens. So what is pod escape? So basically, we do have several definitions, but I use this pretty broad one, where pod escape occurs when a process inside a Kubernetes pod breaks out of its container sandbox. It can gain access to various other resources like underlying node, obviously. That's like the canonical version of pod escape. But it can access also other worker nodes, control plane. It can also move laterally, like to another pod or other containers. Even in the end, if we have a cloud environment, it can access cloud metadata and cloud resources. So why is it so dangerous? That's pretty obvious. We bypass a sandbox, and we are able, as hackers, to tamper with hosts, read all the secrets, escalate privileges. So basically, the sky is the limit. we can end up with controlling the entire node or even the cluster. Pod escape isn't magic. It's like misconfiguration meeting opportunity. Usually it's a combination of misconfigured pod security, running as root, and missing some runtime protection. So those three are the key parts in most of pod escape attacks. It's worthwhile to take a look at Kubernetes OWASP Kubernetes top 10 list. I guess you know it. In 2022, OWASP for the first time published its Kubernetes top 10 security risks list. And many of them indirectly or even directly refers to pod escape, like K1, insecure workload configuration. It's all about the secure configuration of our workloads, and many of insecure parameters allow for pod escape. Then we also, this is connected very strongly to K4, lack of centralized policy enforcement. Why? Because if we have insecure workload configuration, it means that it was allowed to be deployed. So there was no control to reject such insecure workload. So no admission controller which checked whether or not it's okay to create such resources. And another important piece usually is missing network segmentation controls, K7. You know that with Kubernetes, we have this flat network security model where each pod can communicate with any other pod by default. And if we have many workloads deployed to the same cluster, it is like a security risk, right? Because by default, there is no control. So we need some sort of network policies or to control our network segments. Also, K9 and K10 are important misconfigured cluster components and outdated and vulnerable Kubernetes components. It doesn't happen perhaps so often, but yeah, this year we had this Nginx ingress vulnerability, pretty famous and pretty serious one. So it happens from time to time, so we need to take care of this as well. Let the fun part begin where we have some demos, right? It's gonna be like 101 in Kubernetes hacking. So those are like pretty basic scenarios, but hopefully you will see the danger how a series of simple misconfigurations can lead to a total compromise of our clusters. Here I will need your help. I have this demo application available under kcd.yonlabs.com. I have a kind request to you. Please register a new account. Each account has secret data. Log in and wait to be hacked. My objective here is to hijack your account and learn your secrets. So I will give you a couple of seconds to scan the URL. And you see like a simple application. Don't use your real data. It could be leaked during our talk, so be careful. No real data, no real usernames, no real passwords. So just create a new account and log in. You see your profile. You see also active users. So we do have some active users. Thank you for joining and thank you for your cooperation. If you take a look at this application and you see a session storage and a token here. So this is like a JWT-based application. And this token, if you take a look at it, okay, this one. If you take a look at this token, it uses HS256 algorithm. This is HMAC with SHA-256. What does it mean? This is important. Why? Because HMAC is a symmetric algorithm. So basically, to have a JWT-based app with a symmetric algorithm, I need to find out the secret. Then I can generate new JWT tokens easily. So I have two attack vectors here for JWT-based apps. I can steal an existing generated JWT token, one of your tokens, or I can find out a JWT secret and I can generate a new token impersonating one of your accounts. So obviously I won't do like the full hack because there is like a series of steps, and one of them is initial access to the cluster. So I will have the initial access to my cluster. I will be able to create new pods and to exec into a pod. And then I will show you how by pod escape I can escape container escalate privileges or move laterally and ultimately get one of your tokens or find out JWT secret used in this app. Okay, so it's time for demo. I will use my evil server. I will log into my evil server. I'm John Doe here, and John has some privileges already assigned, pretty limited because it is only one namespace and it's basically available to create pods, deployments, and exec into a pod. So let's start with like pretty obvious one. This obvious one is this manifest. So I'm creating a privilege pod with host PID set to true. So privilege pods, obviously, they have really wide privileges here. Also, I'm trying to schedule this pod on the control node. This is not necessary, but I want to show you like different paths and different scenarios. So let me create this this pod and let me exec into this pod. Then you will see how easy it is to move to the node once you have a privileged pod. I do remember my first months of working with Kubernetes, and obviously this dev and prod environments and different switch. And obviously we use privileged pods to debug a lot of things. And why can't we do that in prod? Because this is like too much access for the prod environment. Okay, so we are on the pod now. You see that this is like Linux prevent hostbit pod container. And what can we do here? You see that we have also host PID set to true. It means that we see all processes on the host. So specifically, we see this as being init process, number one. This is important because we want to enter the namespaces of this process. Probably you know the Linux concept of security based on namespaces, right? Capabilities and namespaces are the key elements in Linux security. So we are root here. We can enter enter namespace, enter namespaces of our target process, as been init process, all namespaces, and we want to have bash. So you see already that I'm basically at the moment I'm on the node. So that was so easy once you have privileged pod and host PID configured. What can I do here? I'm also on the control plane, so I do have access to the etcd process. If I can access etcd, you know that this is this key value store which basically stores the entire state of the cluster. So we have a data directory here with all the data. So let's try to enter it. And let's try to read the database. That's this file. We can use strings to show this database, this file in string format. And what we are interested in is like, first let's see pods. We can see like some pods. We can take a look at our demo pods. We see some demo server pods here. So let's see a little bit more about those pods. I want to see like what's going on here. So basically, obviously, you need to analyze, as a hacker, you need more time to analyze all those data, but I know what I'm looking for. I'm looking for JWT secret key here. So I see that this pod uses basically demo secret. So what I need to do, I need to see demo secret here. I do have two of them because I've been updating my secrets, so I do have some previous versions as well. And you see that basically I do have this base 64 encoded JWT secret key, which I would like to use now. So I can use jwt.io page and use some other ID. Let's take 5. And let me see whose account has been hacked. That's Loki, you've been hacked. Are you here? Who are you? Thank you for your cooperation. So obviously that was pretty wide permissions, privilege and host PID and root. Let's drop privileged here. I will show you how we can use sys module capability to also escape to node. So let me move. Okay, I need to get back to my evil server. Okay, we are here and I have this manifest ready. So basically this is not privileged pod. I have only just have the sys module capability configured. So let's apply this one. Let's again exec into this pod and see what I can do over there. So basically, this module capability, it means that I can load new kernel module. So I need to prepare and compile a new module. I have a template ready. This is a simple module. And here you have like two functions, init mode and exit mode. Init mode is like when we load a kernel into a module, exit when we remove it. But here with init mode, we have the start shell function. So basically, I'm trying to establish a reverse shell to my evil server. So what is a reverse shell? Basically, in a regular SSH situation, when you want to access a remote machine or a pod, you just exec SSH into a machine and you need to provide credentials. Then you are given a shell. A reverse shell is the opposite. So instead of a client machine connecting to a remote machine, we have a remote machine connecting to a client machine, this way bypassing any authentication or initial steps. So I will try to establish this reverse shell. So basically, I need to compile this on my pod. I need to make file for this as well. That's pretty simple. Oops. I guess I need like, it should have been here. But wait a moment, I will install build essentials. Yep. I need those. I need build essentials and Linux headers. Okay. Hopefully it will help. Yep, I must say that I've tested all my demos, but you know, demo gods are perhaps not that angry with me. Fingers crossed, right? Okay. We do have now this new module, and I need a second session here. Why? Because I need to, once I load this module, it's gonna execute this reverse shell, so I need to have some process listening on my evil server. So okay, I'm on my evil server, I'm listening, and now I need to load this module, and you see that I received a connection. So basically here, I'm again on the node. What can I do here? I'm not on the control plane here, I'm on a regular node. I do know that this JWT secret was mounted as an environment variable. So basically, I need to access environment variables of a process which runs this pod. So I can see the pods here. I can see my demo server pod. And what can I do? I can inspect to find out. Let's see. I can inspect to find out PID of this process. So that's this one. And now to see environment variables, I just need to access this file from proc folder. Okay. Apps, we have like not fully interactive shell, so I can't go back. I don't have a history here. So I had to copy this one. I want to display this in a more visible format. So we have this secret. You see that this secret is not base 64 encoded now. Okay, so we can use it the same way, but let's target user number 7 here, no encoded, and we have a new JWT token, which I simply replace my token in my browser, and now it's like, Thomas, are you here? Yeah, thank you. So that was very nice demo of kernel module with sys module capability. The problem here is like the sys module capability, but also secrets management failure, unencrypted secrets, and like available as environment variables. I would like to show you one more demo because it shows like another attack path. I will try to make a pod with host network, and then I will have access to the underlying host network. What does it mean? If you know how CNIs work, you know that usually CNIs create like virtual interfaces for each pod. So underneath on the host, you have like virtual interfaces for all your pods. So if I have access to the host network, I can sniff packets on all interfaces available in the host. So I could like sniff some sensitive traffic here, like your tokens. So just one last demo here. Which shows the sniffing, but let me get back to my evil server. I have this manifest. Let me apply it. Let me exec into this pod. And I have everything ready together with TCP dump. So it should be a piece of cake to capture your tokens. So you see all the interfaces here, virtual network interfaces created by CNI. And now I just only need let me find. Okay, I don't have TCP lab. I don't know which port I want to target, and now I have a question for you. Please refresh the pages in this web app. Okay.
Yeah.
I do see some traffic coming, and I just need. Okay, too much traffic. Please stop. Okay, and let me find bearer token here. Okay, I do have some bearer token, and now it's a piece of cake. I need to just replace the token. You know the drill. And now I'm Yonki. Are you here, Yonki? Or perhaps do you have some like oh, you're here. Thank you. Thank you. That's very nice of you. Okay, so that's it for the demos. With this third demo, you see host network is pretty wide as well. And to combine with unencrypted communication inside the cluster, we could get access to the sensitive data. I also had very nice demo about host path with var log. you could get like full access to the entire file system with varlock mount only. Network segmentation, no network segmentation by default. So we have completely regular pod, and we can access any other services on other ports, even not in some cases when you have this flat network security model, which combines pods and nodes together. But we don't have time for this. It's important to highlight like typical pod escape vectors when you have this insecure workload configuration. So take a look at this. Missing network segmentation, that's important part as well. So far we focus on the Kubernetes side, but there is also like the kernel side. With some kernel vulnerabilities and exploits, you can escape pods, even properly configured pods. So like dirty pipe, dirty cow, those are kernel exploits which allow for this. So the answer here, obviously, is like pod security standards, pod security admission controllers. So we need to have those security mechanisms in place. You can use extended versions like Kverno or OPA gateway just to configure more sophisticated security mechanisms. I can only say that this is like the tip of the iceberg when it comes to Kubernetes security, but hopefully you've seen like simple misconfigurations can lead to a total compromise of the entire node. It's important to remember about the Swiss cheese security model when we have multiple layers of security mechanism and control, because like the slices of cheeses, those security holes one slice can cover the holes in another slice. What can I say? A fool with a tool is only a fool. So we need to keep educating ourselves. So that's for what conferences are for, right? So good that we all are here and enjoy hacking together. Thank you.